Introduction. Students, look at these numbers. What can you say about these numbers?
These numbers are in sequence, ma'am.
Yes, you're right. These numbers are in sequence.
Ma'am, what is a sequence?
Okay, fine. Today I will explain you about sequences and series. Shall we start?
Yes, ma'am.
Objectives. At the end of this lesson, you will be able to understand sequence, explain general terms of the sequence, understand the finite and infinite sequence, understand series and progression, learn arithmetic progression, explain properties of arithmetic progression, learn sum of the n terms of an AP, learn arithmetic mean. Sequence. A set of numbers arranged in a definite order according to some definite rule is called a sequence. The various numbers occurring in a sequence are called its terms. The terms of a sequence are denoted by A1, A2, A3 till AN, etc. The nth term is the number at the nth position of the sequence and is denoted by AN. The nth term is also called the general term of the sequence. Sequence 2. Infinite or finite. If the sequence goes on forever, it is called an infinite sequence. Otherwise, it is a finite sequence. 1, 2, 3, 4 and so on is a very simple sequence and it is an infinite sequence. 20, 25, 30, 35 and so on is also an infinite sequence. 1, 3, 5, 7 is the sequence of the first 4 odd numbers and is a finite sequence. A sequence usually has a rule which is a way to find the value of each term. Example, the sequence 3, 5, 7, 9 and so on starts at 3 and jumps 2 every time. A sequence can be regarded as a function whose domain is the set of natural numbers or some subset of it of the type 1, 2, 3 up to k. Sometimes we use the functional notation a, n for a, an. Example of sequence. Write the first 3 terms of the sequence defined by an is equal to 2n plus 6. Solution. Given an is equal to 2n plus 6. Substituting n is equal to 1, 2, 3, we get a1 is equal to 2 into 1 plus 6 is equal to 8. a2 is equal to 10. A3 is equal to 12. Therefore, the required terms are 8, 10 and 12. Series. A series is the sum of a sequence. Here is a sequence. 1, 2, 3, 4, 5. Here is the corresponding series. 1 plus 2 plus 3 plus 4 plus 5. We have a special notation for series. We use this Greek letter, that is sigma. It is an S in the Greek alphabet. Think of it as an S for sum. Our series adds 5 terms, 1 plus 2 plus 3 plus 4 plus 5. Here is the official notation. Summation from k is equal to 1 to 5 of k. So, for this sequence, whose nth term is given by an is equal to n, the summation can be found as given and it is found to be 15. Arithmetic progression AP. An arithmetic sequence or arithmetic progression is a sequence, finite or infinite list of real numbers for which each term is the previous term plus a constant called the common difference. For example, starting with 1 and using a common difference of 4, we get the finite arithmetic sequence 1, 5, 9, 13, 17, 21, and also the infinite sequence 1, 5, 9, 13, 17, 21, 25, 29 till 4n plus 1. Let us consider an AP in its standard form with first term A and common difference D, that is A plus D, A plus 2D, and so on. Then the nth term, that is general term of the AP, is AN is equal to A plus n minus 1 into D. Also, L is equal to A plus n minus 1 into D, where L is the last term. Also, Sn is equal to n by 2 into 2A plus n minus 1 into D, or Sn is equal to n by 2 into A plus L, where Sn is the sum to n terms of AP. Properties of arithmetic progression AP. If A1, A2, A3 up to AN are in arithmetic progression, then A1 plus minus K, A2 plus minus K, A3 plus minus K up to AN plus minus K, where K belongs to R, are also in AP. KA1, KA2, KA3 up to KAN, where K belongs to R and K0 equals to 0, are also in AP. A1 by K, A2 by K, A3 by K up to AN by K, where K belongs to R and K0 equals to 0, are also in AP. Reversing the order of an AP also results in an AP. That is, AN minus 1 up to A3, A2, A1 are also in AP. Addition or subtraction of two different APs also results in an AP. Suppose B1, B2, B3 up to Bn are also in AP. Then A1 plus minus B1, A2 plus minus B2, A3 plus minus B3 up to AN plus minus Bn are also in AP. Example of arithmetic progression AP. Example: let sum of n terms of a series be n into 2n minus 1. Find its mth term. Solution: let Sm and Sm minus 1 denote the sum of first m and m minus 1 terms respectively. Sm is equal to T1 plus T2 plus T3 up to Tm minus 1 plus Tm. Sm minus 1 is equal to T1 plus T2 plus T3 plus up to plus Tm minus 1. Tm can be found as Tm is equal to Sm minus 1. On solving, we get 4m minus 3. Example of arithmetic progression AP. Example: if the first and second terms of an AP are 1 and minus 3 respectively, find the nth term and the sum of the first n terms. Solution: let first term is equal to A, second term is equal to A plus D, where A is equal to 1, A plus D is equal to minus 3. It implies D is equal to minus 4. It implies AN is equal to A plus n minus 1 into D is equal to 1 plus n minus 1 into minus 4 is equal to 5 minus 4n, and Sn is equal to n by 2 into A plus An is equal to n by 2 into 1 plus 5 minus 4n. It gives Sn is equal to n into 3 minus 2n. Arithmetic mean. The arithmetic mean, or simply the mean or average, is the central tendency of a collection of numbers taken as the sum of the numbers divided by the size of the collection. Mean is equal to sum of elements by number of elements is equal to A1 plus A2 plus A3 plus up to plus AN by n. Example: to find the mean of 3, 5 and 7. Step 1. Find the sum of the numbers, that is 3 plus 5 plus 7 is equal to 15. Step 2. Calculate the total number. There are 3 numbers. Step 3. Finding mean. 15 by 3 is equal to 5. Examples of arithmetic mean. If 6 arithmetic means are inserted between 1 and 9 by 2, find the 4th arithmetic mean. Solution. Let A1, A2, A3, A4, A5, A6 be 6 arithmetic means. It implies 1, A1, A2 up to A6, 9 by 2 will be in arithmetic progression. Now 9 by 2 is equal to 1 plus 7d. It implies 7 by 2 is equal to 7d. It implies d is equal to 1 by 2. Hence, A4 is equal to 1 plus 4 into 1 by 2 is equal to 3. Did you know an arrangement of numbers such as 1, 1, 2, 3, 5, 8 and so on has no visible pattern, but the sequence is generated by the recurrence relation given by A1 is equal to A2 is equal to 1, A3 is equal to A1 plus A2, AN is equal to AN minus 2 plus AN minus 1, n is greater than 2. This sequence is called Fibonacci sequence. Summary. Let us summarize what we have learnt. By a sequence, we mean an arrangement of a number in a definite order according to some rule. Also, we define a sequence as a function whose domain is the set of natural numbers or some subsets of the type 1, 2, 3 up to k. A sequence containing a finite number of terms is called a finite sequence. A sequence is called infinite if it is not a finite sequence. Let A1, A2, A3 and so on be the sequence, then the sum expressed as A1 plus A2 plus A3 plus and so on is called a series. A series is called finite series if it has got finite number of terms. An arithmetic progression, AP, is a sequence in which terms increase or decrease regularly by the same constant. This constant is called common difference of the AP. Usually we denote the first terms of AP by A, the common difference by D, and the last term by L. The general term or the nth term of the AP is given by the sum Sn of the first n terms of an AP is given by the arithmetic mean capital A of any two numbers A and B is given by this. That is, the sequence A, capital A, B is an AP.